Today is the 16th. Okay. I'll tell you guys when I want you guys to write, but for now, can you guys just pay attention and watch what I do? So what the writing says is the graph of the function g of x is shown to the right. We want to approximate the area under the curve on the interval 2 to 6 with n sub-intervals by using a left rectangular approximation method. Okay, so in this section, you guys will learn what that means. So in the last section that we did, didn't we find areas of things that had like nice geometric shapes, like triangles, semicircles, rectangles? Okay, here though, from 2 to 6, so like I said, don't do anything yet, just watch what I do. If I were to draw the area under the curve from 2 to 6, okay, you guys agree like from here to here is a rectangle, right? But because of the curve and it bends, this kind of looks like a triangle, but it's not a triangle. So there's no easy way to find the area under the curve because this isn't a nice geometric shape. So in this section, what we can do is instead we can use rectangles to approximate what the area would be. Okay, so watch what I do. Don't do anything yet. So what this says is the area from 2 to 6 with n sub-intervals. All these problems, it'll tell you guys how many sub-intervals it wants you guys to do. So let's say it wants us to find n equals 1 sub-intervals. So what that would mean is to find the width, all you do is you do the endpoints. So like this is like from A to B, okay? So what you would do is you would do 6 minus 2 divided by 1, which is 4. Okay, so what that means is the width of my rectangle I'm going to draw is going to be 4. So from here to here, do you guys agree that's a length of 4? From 2 to 6? Does that make sense? A left rectangular approximation. So what that means is I'm going to draw a rectangle on the left side of this interval. So do you guys agree that the left number would be 2? Okay, so what you're going to do is you're going to draw a rectangle that goes from the x-axis to where the function meets, so like right there. And I would draw a rectangle like that. Okay, but if I'm trying to find the area under the curve, do you guys agree that I'm also not getting all this area by doing that? So do you guys think this is going to be a good estimation? The answer is no. Okay, so we don't want to use one interval. So let's see what happens if I pick, I don't know, 4. So let's pick 4. So if the width is 4, or sorry, if n is 4, then the width is going to be 6 minus 2 divided by 4. What's 6 minus 2? 4. What's 4 divided by 4? 1. So that means the width of each rectangle is going to be worth 1. So from 2 to 3, that's 1. From 3 to 4, that's 1. From 4 to 5, that's 1. And from 5 to 6, that's 1. Okay, now you guys can draw. If it's a left rectangle approximation, that means that this is worth 1, right? From 2 to 3. This width is 1. Do you guys agree the left of these numbers is 2 of 2 and 3? So at 2, I want you guys to draw a point at where the function meets. So that's going to be like the height of your rectangle. I'm going to go from the x-axis to that point, go across, and then come down. Okay? Now, this means that we're going to have 4 rectangles. So from 3 to 4, I have another rectangle. So same thing. At 3, because this is the left, this is the left of these two numbers. So I'm going to draw where the function meets at 3. And that's going to be the height of this rectangle. Okay? Same thing from 4 to 5. Where the function meets at 4 is right there. So I'm going to draw across and down. And at 5, the height's going to be right here. Go across and down. So these would be my 4 rectangles that I would use. So understand, guys, is this a better approximation than what we just did with 1? It's because what I'm trying to get you guys to understand is this is going to get me more of my area. I'm still missing, if you guys can look, I'm still missing this piece, I'm still missing this piece, and I'm still missing this piece. But from 1 to 4, we increase the number of rectangles, right? So the more, what I want you guys to understand is the more rectangles you use, the better estimate this is going to give you. Okay, so this is the idea. Obviously, the more rectangles you guys draw, isn't our picture going to look kind of crowded and tough to draw, right? So you want to try to guesstimate the area as best you can. For these problems, though, I'll tell you what to do, okay? So this approximation is called a Riemann sum. And this is usually an FRQ question, is using these. I shouldn't say usually. It has been a lot in the past, though. It was named after a German mathematician named Bernhard Riemann. Okay, before we move forward, does anybody have any questions? And I'm recording this, okay? So you guys can come back and watch it if you guys need to. But just don't be shy, guys. If you guys need help setting these up, please come ask, okay? So we're actually gonna solve a problem now like we would on an AP test right now. So it says below is the graph of f of x is equal to 4x minus 1/2 x squared. Use Riemann sums to find the approximation of the area under the curve. Okay, in about a week and a half to 2 weeks, you guys will actually learn how to find the exact area under the curve. So I don't want an exact area, so please don't Google what the area under the curve is of this, because then I won't trust you. I need you guys to approximate using the methods, okay? So we're gonna do a left sum and we're gonna do a right sum. So there's a difference between the two, so pay attention. If I wanna do a left sum, all of these problems, the first step is the same. To find the width, I want you guys to write this down and put a box around it. The width is always b minus a divided by n. Where a is the first number in the interval, b is the second number, and the number of subintervals they tell you, that's n. Okay, so the width, we have to find that first. That's going to be 8 minus 2 divided by 3. What's 8 minus 2 divided by 3? 2. Okay, so that means that for all my rectangles, the width is going to be 2. Okay, so where are we starting on the x-axis? What's our a? 2. So what I'm going to do is at 2, I want you guys to draw a tick mark right there. And then since our width is 2, I'm going to draw another tick mark at 4. And then at 6. And then, what? It's up there now. Sorry, it's lagging. Of course, right? Important lesson, and of course the internet doesn't want to work, of course. Okay, is everybody good with that so far? And then at 8, I need another one. All right, which type of sum are we doing here, left or right? Left. So understand, guys, what that means is the height of each rectangle, so between these two numbers, since my width is 2, the height is going to be the left of those numbers, because that's what it tells us to do. So because it's left, you're going to draw a point where the function meets x equals 2, so that's going to be right there. So that's going to be my height, and our width is 2, so I'm going to go over 2, and then just draw straight down to the x-axis like that. So that's our first rectangle. Okay, do the same thing from 4 to 6. So which one's going to be my height? The 4 or the 6? The 4. So at x equals 4, I'm going to draw a point where the function meets at x equals 4. So this is going to be right there. And then our width is 2, so go over 2, and then down to the x-axis. Okay. Between 6 and 8, 6 is our left value. So I'm going to draw a point right there when x is equal to 6 on the curve. Go over 2, and then down. If you guys are using your iPad, this is going to be a really fun homework to do because you guys can use as many colors as you want. For those of you guys doing it on paper, I would strongly suggest using different colored pens, okay? Because that way you guys can see what's happening. All right, is everybody, don't be shy guys, is everybody comfortable with where these came from? Okay, so this is the important part. How do you find the area? Do you guys agree that for a rectangle, area is equal to base times height? Right? So we're going to find base times height plus base times height plus base times height. But what you guys are going to notice right now is there's a pattern to these. So watch. So the area is going to be, I'm actually going to write it over here so I have more space. Area is equal to base. So how wide is this rectangle? 2. So it's going to be 2 times the height. So before we write 6, I want you guys to write something first. Do you guys agree this is going to be whatever the function was at 2, the y value? So I want you guys to write f of 2 plus this rectangle. The base is still 2. So 2 times f of 4 plus 2 times f of 6 for the last rectangle. Is everybody cool with where that came from? For the guys wondering, like, why didn't I just write 6? This one's a nice one. They're not always going to be nice. So do you guys see clearly that f of 2 is 6 here? Okay, but if it's not easy to tell, you guys notice that I gave you guys an equation. You guys could technically just plug it into the equation to figure out what that was. Okay, so before we do the math, do you guys notice something about all 3 calculations? What do they all have in common? A 2. So what could I do with that 2? I could factor it out. Okay, so this is equal to 2 times f of 2 plus f of 4 plus f of 6. Okay, so now you guys can use the graph. So 2 times f of 2, you guys said was 6, plus what's f of 4? 8, plus what's f of 6? 6. So you guys can put this into your calculator if you guys want. 6 plus 8 plus 6 is 20. 2 times 20 gives me 40. Hooray. Your whiteboard? Yeah, sure. Questions? Okay. Now, a right Riemann sum. So let's see if you guys understand this. If for a left Riemann sum, we found the left endpoint, for a right Riemann sum, we're going to use the right endpoint. It's literally the same steps, but you use the right endpoint as your height. Okay? So look, before we just jump straight to the problem, remember you always find your width first. But what I want you guys to notice is, do you guys see how it's from 2 to 8, 3 subintervals? It's the same directions here. So the width is going to be the same here, but you always want to check that first. Okay? So the width here is still just 2. Okay, so from 2 to 8, so from 2 to 8, so width is 2, so from 2 to 4, 4 to 6, and then from 6 to 8. Okay, this one's a weird one, to be honest. If I were to make these notes for you guys, I probably wouldn't have given you guys this as a first example, because watch what happens. Between 2 and 4, do you guys agree that 4 is the right endpoint? So that means the height of this rectangle is going to go all the way up here and then go 2 across and down. So it's going to be something like this. Okay, the next interval is from 4 to 6. This is the right endpoint, so the function is right here at 6. Okay, now, it's actually kind of cool, I lied. From 6 to 8, this is the right endpoint, right? What is the y value right here? 0. So guess what the area of this rectangle is? It's just 0. So there is no rectangle right here because the height is nothing. Okay? So area is equal to base times height. So the base of this rectangle is 2. So 2 times f of 4 plus 2 times f of 6 plus technically 2 times f of 8. Again, they all have a 2 in common. So I'm going to factor that out. So this is going to be f of 4 plus f of 6 plus f of 8. F of 4 is 8 plus 6 plus 0. What's 8 plus 6? 14. 2 times 14 is 28. Okay. Now remember, we're approximating this, right? So it should make sense that because we did 2 different strategies, we got 2 different answers. Okay, so I want you guys to kind of understand what the answers mean. Which one's larger? The left one, right? It's 40. So what I want you guys to look at is, do you guys see how the area under the curve, so this is under the curve, this is under the curve, but we included this as part of our answer, right? Is this under the curve? So you guys agree that's like extra, right? And then here, right here, this is a lot of extra. Okay, so this is what we would call an overestimate because we included too much of the area. Here, it's less. So do you guys see how I didn't include all this area and I didn't include all this area? So this is what we call an underestimate because it's too small. Okay, so the next strategy we're going to use is going to be even better. Okay, midpoint and trapezoids are a little bit confusing, so pay attention. Thank you. All right, see you tomorrow. All right. Try to be a trooper. I can't. I'm back. I messed up my back. I don't know. I'm trying to make it better. All right, guys. So midpoint. Before we attack what that means, okay? The width we have to figure out first, but I want you guys to notice it's still the same here, right? So what's our width? 2. Okay, midpoint. So we're starting at 2. Our width is 8, so from 2 to 8, or sorry, 2 to 4, excuse me, 4 to 6, and from 6 to 8. Now, for the left Riemann sum, we use the left value. For a right Riemann sum, we use the right value for the height. Midpoint, we're going to use the middle. So what's the middle between 2 and 4? 3. So that means at 3, the height of this rectangle is going to be whatever the function is at 3. Okay, so I'm going to draw a point right here. And then remember, the width is 2, so I need to go across like this, so it's a width of 2, and then straight down to the x-axis. Okay, is everyone okay with that idea? The next interval is from 4 to 6. Which one is the middle number? 5. So at 5, draw a point on the curve. And from 6 to 8, our midpoint is going to be 7. So a rectangle should look something like that. Okay, so this is where this one's a little bit different. Please don't guess what the function would be. So the area is going to be base, so 2 times, what is the height? F of 3, so 2 times f of 3, plus 2 times f of 5, plus 2 times f of 7, okay? What I want you guys to notice about f of 3, f of 5, and f of 7 is they're not exact values. So this is where the function that I gave you guys is going to come into play. So remember at the beginning, f of x was equal to 4x minus 1/2 x squared. Do you guys remember the other day how I showed you guys you can type this into y equals, make a table and just put ask? Did you guys remember that? I would do that for here just to make your life easier. Don't plug it in for x because then it will take more time than it needs to. Okay, so before we do all that, again, all 3 values have a 2, so I'm going to factor out the 2. So from our calculator, guys, what was f of 3? Okay, so 7.5 plus 7.5 again, plus 3.5. Is everybody okay with where those came from? Okay, just use your calculator, guys. 7.5 plus 7.5, that's what, 15? 15 plus 3.5 is 18.5. 18.5 times 2, 37. Okay. So, comparing the 3 methods so far, we said that the left was what type of estimate? An overestimate. We said the right was a underestimate. Where does our answer fall between those 2 numbers? In the middle, right? So this is going to be like a better estimate because if you guys notice, there's less of the curve that's not, less of the area that we weren't able to get, and there's less extra too. So a midpoint would be a better estimate of the 3. Okay, this one is the hardest of the 4, but this is going to give you guys the best estimate of all of them almost every time, okay? All right, so before we do anything, the area of a trapezoid. I need you guys to know this, okay? The area of a trapezoid is base 1 plus base 2 divided by 2. Base 1 plus base 2 divided by 2. Because a trapezoid normally looks something like this. Okay? The only difference is it's going to be kind of rotated because of the way that our trapezoid is going to be drawn here. You guys will see what I mean. All right. Find your width. Our width is still 2. So, starting at 2, so from 2 to 4, 4 to 6, and from 6 to 8. So the way that we're going to draw trapezoids is like this. Our base is 2, right? So what we're going to do is we're going to draw a point at 2, and we're going to draw a point at 4 on the curve. Like this. We're going to connect the dots. And then we're going to draw sides straight down to the x-axis. Okay, so this is one trapezoid. From 4 to 6, draw a point at x equals 4, so right there. And we're going to draw a point at x equals 6. Connect the dots. And then go straight down. From 6 to 8, same thing. We already have our point at 6. Draw a point right here. And draw a line straight down. So that, check it out, guys. That gives us a pretty good estimate of that part of the graph, right? Because there's barely anything there that's not going to get accounted for. So this is interesting because what shape is this? It's a triangle, okay? All right, so how do you use the formula to do this? So this is what I want you guys to understand. Do you guys agree that the width is still 2 for all these? So it's going to be 2 times, we have to do base 1 plus base 2 divided by 2. So we have 2 different heights, right? So this is how you're going to do the area. So the area is going to equal, write a little bit small so it fits, 2 times, the bases here are going to be f of 2, so that's base 1, plus f of 4, that's base 2, divided by 2. Okay, plus 2 times, for the middle trapezoid, it's going to be f of 4 plus f of 6, all that divided by 2, plus 2 times f of 6 plus f of 8, and all that divided by 2. Okay, before you guys put it into your calculator, hold on. Do you guys notice something about all 3 calculations? Yeah, good. So in this case, you guys see how we have a 2 and a 2. All the 2's are going to cancel. Okay, so watch what's left over. This is kind of cool. You get f of 2 plus, check it out. We have an f of 4 and we have another f of 4. So we have plus 2 times f of 4 plus, we have an f of 6 plus another f of 6. So 2 f of 6 plus f of 8. So in the last problem, we got to plug it into our function. Do we have to plug it into our function for this problem? Or are all the values nice? They're nice. What's f of 2? So this is going to be 6 plus 2 times 8 plus 2 times 6 plus 0. So 6 plus 16 plus 12 is 34. So remember what I told you guys, the trapezoid is going to most likely always give you the best estimate. Okay, on your homework, you won't have to do all 4 in the same problem. This is just demonstrating how to do them. Okay? Okay, so before we move on to the next part, besides my soccer friends, do you guys have any questions? No. The last question in these notes and the last question on your homework is a almost exact copy of what an AP question would look like. Okay? And it's a word problem. Okay. All right, so we were talking about increasing, decreasing. I'm sorry. We were talking about overestimating or underestimating. I'm gonna be honest, you don't have to memorize these rules because I'll show you guys how you guys can determine this or not. So let's just say we're given an increasing function. So to keep it simple, let's talk about a line that's going up. Okay? If I were to do a left Riemann sum. So for example, let's say I wanted to do it. It doesn't matter what interval you pick. So let's say I want to do it from 1 to 4. Remember, if I'm doing a left Riemann sum, that means I'm picking the left endpoint for my height, right? So that would be right here. And my rectangle is going to go all the way to 4. So if I want to use a left Riemann sum to estimate this area, do you guys see how I'm not getting any of this area? So is this an underestimate or an overestimate? This would be an underestimate. Okay? If it's a right Riemann sum, let's do the same thing. Let's pick from 1 to 4. Because this is the right endpoint, that's my height. So is this an overestimate or an underestimate? This would be overestimate. Okay? For decreasing, let's see what happens. Pick an interval, guys. I don't care. 1 to 3. I heard 1 to 3 first. Sorry, Carlos. 1 to 3. So from 1 to 3. If I want to do a left Riemann sum, that means my left endpoint's my height. So what do you guys notice? This is an overestimate. Okay, for a right Riemann sum, I'm going to pick the same interval from 1 to 3. So this is going to be my height. So this would be an underestimate. Like I said, if you guys can't remember these rules, if you know your function's increasing, for example, just draw an increasing function and then just draw a rectangle. And you guys will see whether it's an overestimate or underestimate, okay? It's pretty straightforward. Okay. Now, if it's a trapezoidal estimation, and we know something about concavity. So remember, concave up is like teacup. Concave down looks like an umbrella. So if I want to talk about from 1 to 4. Sorry, I hear you guys taping. That's the way I learned it. I know. I think of like Mary Poppins, like tea, an umbrella. I don't know. All right. From 1 to 4. So if I want to do a trapezoid, that means I'd be looking at this height and then that height. Connect the dots. So if you guys notice, I get pretty much all of the curve, but also some extra. So this would mean it's an overestimate. And if we know the function's concave down, do you guys see how there's still this part of the area that we didn't get? Yeah? So that would mean that this is an underestimate. But again, it's pretty close. This is without doing what you guys will learn in a couple weeks, this is as close as we can get. All right. You guys have a question like this on your homework. And like I said, this is something that I would really make sure you guys understand. So if you guys have like sticky notes, I would actually put like a sticky note in your notebook for this type of problem, because this is something that if you guys remember how to do this on the AP test, you guys will get a lot of points on that FRQ. The rate at which water is being pumped into a tank is given by the continuous and increasing function R of t. A table of selected values of R of t for the time interval from 0 to 12 minutes is given below. Okay, the only difference here, guys, and what we're going to do is you have a table instead of a graph. You don't have to graph this. You just have to think about what it's saying. So it says use the following Riemann sums to estimate the number of gallons of water pumped into the tank during the 12 minutes. Okay? So we are finding the area under the curve, right? Using a Riemann sum. You guys with me? Do you guys remember that we talked about in 6.1? To find the units, don't we multiply the x and the y? Do you guys remember that? So if I take minutes and multiply it by gallons per minute, what's going to cancel? The minutes. So it means our unit of our answer is going to be in gallons. So hopefully that makes sense. Okay, so I'll write Riemann sum. Remember that to find the width, okay, you're going to do A to B, so B minus A divided by N, okay? However, that only works if the distance between each value works. So this is a warning for your homework. You need to pay attention to how far apart the x's are, okay? So conveniently here though, what's the distance between 0 and 3? 3 to 6. 6 to 9. 9 to 12. So the width here is always 3. So that's nice. So from here to here, that's 3, 3, 3, 3. Now, what I want you guys to think about is, if this is my rectangle on a graph, I would start at 0 and the width would be 3 till I get to 3, okay? So which of these is the right endpoint? Which of these would be the right endpoint, 0 or 3? 3, because it's bigger. That means that the height would be the 13. Sorry, my laser's like lagging really bad. Of course, right? I'm gonna go up there because I'm annoyed. Let me say this again. If this is my first rectangle, from 0 to 3, you guys agree that's 3. If I'm doing a right Riemann sum, do you guys agree that the right value is the 13? That would be the height, okay? For this rectangle, from 3 to 6, this is the right number, so that would be my height. From 6 to 9, this would be my height. From 9 to 12, this would be my height, because those are the right values for each of those, okay? So the area is going to equal, what is the width of all these? 3. So the first one, if we're talking about this interval, is going to be 3 times, which one is the right value? 13. So 3 times 13 plus 3 times 18 plus 3 times 23 plus 3 times 27. Is everybody cool with where that came from? Okay. What do all these calculations have in common? 3. So what can I do with that? Factor it out. So 3 times 13 plus 18 plus 23 plus 27. 50 plus 31 is 81. Check my math, guys. Yeah? Okay. Kind of pause. Does this make sense? Does everybody follow me? Yeah? Now it says, is this approximation greater or less than the true value? So is this an overestimate or an underestimate? That's what it's asking you. So what do we know about the function? The function is increasing. And you can tell also because you guys see how the gallons are increasing as time goes on. Okay, so let's say that you forget the rule. You don't have to memorize the rule. So what I was telling you guys could do is just draw a function that looks like it's increasing. Okay? Then if I'm going to do a right Riemann sum, so let's say this is my interval. Do you guys agree a right Riemann sum would look something like that if I want to draw my rectangle? Based off my picture, is this an overestimate or underestimate? This is an overestimate. So you could say this is greater since the function is increasing. Hey. Yeah. And it's a right Riemann sum. It's up top. Yeah. Computer paper or oh, computer paper? I think it's up there too. I'm sorry. Yeah. It's behind the whiteboards. I think. Oh, sorry. Did I use it all? Might be here then. I'm sorry.
Thank you.
No.
Let me know if you do that.
Can I borrow scissors? How much are we?
Sorry about that. Thanks.
All right. Are we okay? All right, let's do a left Riemann sum. So same idea, 4 subintervals. So we already have it set up for us because we know that the width of each one of these rectangles is going to be 3. But the difference is the left Riemann sum, we're going to use the left value every time. Okay, so it's going to be, area is going to equal 3 times what? 7 plus 3 times plus 3 times plus 3 times 23. Again, since you notice that they all have 3's, I would factor out the 3. Oh boy, 20 plus 18 is 38. 38 plus 23 is 61. 61 times 3 is 183. Yeah, okay. You good? Okay. Questions? Okay, so same idea. Pretend like it's May 12th and you're stressed and you have this type of question you don't remember. Increasing looks something like this. If I were to draw just a rectangle, a left Riemann sum would look something like that. So this represents an underestimate. So is it greater or less? I'm going to say it's less because since we know our function is increasing, and it's a left Riemann sum. Okay. So far so good? All right, midpoint. Pay attention to the directions though. How many intervals are we doing now? 2. Okay, so we gotta be careful. So you guys have it in front of you. I'm gonna copy and paste the table so I don't have to keep scrolling up and down. Okay, so 2 subintervals. So 0 to 12. That's a distance of 12, right? 12 minus 0 gives me 12. What's 12 divided by 2? 6. That means the width of each rectangle is going to be 6. So that means I'm going to have one rectangle from 0 to 6, and then another rectangle from 6 to 12. Okay, so this width is going to be 6, and this width is going to be 6. Okay, so since I have 2 intervals, 2 rectangles, midpoint means I'm picking which of these numbers? The middle, right? So I'm going to pick the 13. Here I'm picking the middle, so I'm picking the 23. Okay, so the area here is going to be the width, so 6 times the middle value, so 13, plus 6 times the middle value, which is 23. 6 times 13 is 78, 6 times 23, what is that, 138, somebody? 216? Yeah. Oh, thank God. I thought there was another part to this. This is it. And now our favorite, the trapezoids. No, it's funny, like going into this class, teaching this class and preparing for this class, I forgot about these. I guess I just blocked that trauma out of my mind. These ones aren't that bad, but they're annoying 'cause it's a lot of work. Okay, so 4 subintervals, so same thing, 0 to 12. So 12 minus 0, that's 12 divided by 4. So that means my width of each one of these is going to be 3. So one interval, another interval, another interval, another interval. So all these are worth 3. Well, like I said on your homework, you guys are warned. Make sure you guys check the distance between all these because it may not be the same, okay, on a table problem like this. So the trapezoids, remember, you're basically like averaging the heights. So it's going to be the width times this plus this divided by 2. The width times this plus this divided by 2. Because remember from earlier, it was like f of 2 plus f of 4 divided by 2. This would be like your f of 1 plus f of 2 divided by 2. So it's going to be the width times 7 plus 13 divided by 2 plus 3 times 13 plus 18 divided by 2 plus 3 times 18 plus 23 divided by 2 plus 3 times 23 plus 27 divided by 2. 7 plus 13 is 20. 20 divided by 2 is 10. 10 times 3 is 30. Plus 31 divided by 2, 15.5 times 3 is 46.5. Plus 61.5 plus 75. 108, 138. Someone check my math. It's correct? Hey. Sorry, I wanted to flex on you guys a little bit. I want to see if I could do it.